Hello viewers, in this tutorial we'll be looking at how to find the determinants of matrices. So here we have that let A be a square matrix. So what is a square matrix? A square matrix is a matrix where the number of rows is the same thing as the number of what? Of columns. So that is what a square matrix is. For example, 1 by 1, 2 by 2, 3 by 3, 10 by 10. Those are square matrices. So let's consider the first case, which is a one by one matrix. So how do you find the determinant? But before we go into that, we see here that we denote the determinant of a matrix by using this two. So you can use any one. You can just say det. Det means determinant of A, or you use an absolute value. So, but here it doesn't mean absolute value. It means determinant. And determinant can be negative, determinant can be zero, determinant can also be what? It can be positive. So this is not like a magnitude in the case of vector or absolute value, right? So take note of that. It's just a notation for determinant. Now, here, if you have a one by one matrix, the determinant is just the element, which is A. So for example, if I have A to be equals to what? 3, what will be the determinant? This is a one by one matrix because you have one row, one column. So for a one by one matrix, the determinant is just that element, which is 3. Now for a 2 by 2 matrix, we have this formula here for 2 by 2 matrix. If you have 2 by 2 matrix with this entry A, B, C, D, then the determinant is just what? The product of this diagonal, the element in the main diagonal, then you subtract what's the product of the elements in the minor diagonal. So for example, if you want to find here, find the determinant. So the det of A is just going to be 9 multiplied by 2, then subtract what? 8 times 1. So what is this one? This is just going to be 18 minus 8, which is just 10. So the determinant is 10. So for this one, you want to find that B, we can use this. Determinant of B is just what? 6 multiplied by 3. Then minus, here you see you have 2. 2 times what? Minus 3, right? So this is going to give us 18 minus 2 times minus 3 is minus 6. So this will give us just 18 plus 6. So the determinant is equals to 24. All right. Then, so for example 2, we want to find the solution set. Here, please take note, you can see that here is just like the absolute value sign, right? So it's not a matrix, it's already a determinant. So here we are told that the determinant of this 2 by 2 matrix is what? Is half. So we want to find the solution set, which is like finding the variable, which is alpha, right? So since this is a 2 by 2 matrix and this is already the determinant, so how do we find the determinant? We multiply this, so this will be sine. You can call this, so it means sine of what? Alpha times cosine of 2 alpha minus, then you multiply this and this, so you will have minus sine 2 alpha, then times minus cosine of alpha, right? This is how to find the determinant, but this is going to be equals to what? Equals to half. Now if you look carefully, you will see you can write this as sine alpha cosine 2 alpha. This minus and minus will go, so this will just be minus, And this you can rewrite it as what? Cosine alpha sine 2 alpha. This is equals to this. So you can remove this bracket actually. There's no need. Now, if you remember that this is it difference of angles when we did trigonometry, you will see that this is nothing but sine alpha minus what? 2 alpha. Remember, because we said if you have sine A minus B is the same thing as what? Sine A cosine of B minus what? Cosine of A sine of B. So alpha in this case is our A, and 2 alpha it's the B. So it means this is equals to what? Half. But what is sine alpha minus 2 alpha? This will give us sine of minus alpha. It's equals to half. Is that okay? Then we can see from here that sine is odd, so we can take minus out. So this is minus sine alpha. It's equals to half. And this means that what? Sine alpha, it's equals to minus 1 over 2. Okay, but the question asks us to find what? To find the solution set. So if we're looking for the solution set, it means we need what? We need the solution, right? So what is it going to be? Here, if you remember, this is how to solve this kind of problem. We see that sine is what? Sine is negative in which quadrants? In quadrant 3 and quadrant 4, right? So if you take quadrant, so the first thing you need to do, you need to get like a reference angle, right? You can say an angle in the first quadrant whose sine, I can call it alpha star, whose sine is equals to what? 1 over 2. So, and what is that alpha? That alpha is pi over 6, which is 30. So alpha star here is pi over what? Over 6. You can call this to be your reference. But this angle, you can see this is coming from the first quadrant. But here we need to use this negative. So because sine is negative in the third and the fourth quadrant, then how do you find the angle in the third quadrant? So in the third quadrant, your alpha is going to be what? Is going to be this alpha you got, which is, we can call it the alpha star, plus what? I will have to add pi, right? Because we're in the third quadrant. And what does this mean? This means that it's going to be pi over 6 plus pi, which is what? 7 pi over what? Over 6. Is that okay? Now, not just that, we can add any what? 2k pi will do the job. Any coterminal plus any coterminal will be fine. Then here, the same thing, but here we're in the fourth quadrant. Alpha in the fourth quadrant is going to be what? Is going to be 2 pi minus alpha star, right? Remember, alpha star is like your reference angle, which is the angle in the first quadrant, such that sine of that angle gives you 1 over 2, right? So now this means that what? Let me use implication here. Oh, it's equality is still fine. Or you can use this. So this means that you have 2 pi minus what? Pi over 6. And this will give us what? 11 pi over 6. Then you can add 2 pi, k, right? So here we know what is k. K is in any integer. So what will be the solution set? So our solution set in this case is going to be these two answers. Here we don't have a range for alpha. So it's just this, we just work with the general solution. So you have 7 pi over 6 plus 2k pi, or 11 pi over 6 plus what? 2k pi. And in all of this, your k is what? Is an integer. So this is your solution set. All right. So Now, let's move to another question. Here we are dealing with now we know how to find the determinant of a 2 by 2, a 1 by 1 matrix. So let's look at the determinant of a 3 by 3 matrix. How do you find the determinant of a 3 by 3 matrix? Here we're going to use, in this first part of the video, we'll be using a method which is called the Saros method, Saros rule. And what is that rule? It says if you have a 3 by 3 matrix, please take note, this method only works for 3 by 3. Use it for all the 3 by 3. If you have a 3 by 3 matrix, you have this, as you can see, all you need to do is what? You have to just repeat the first two columns. Look at here, you repeat the first two columns, so you have A11, A12, A13. Then you see this line, right? Then you repeat the first two columns. What is the first two column? This one, A11. This is the first column. You put it here, right? Then now this is the second column. You put it down here. Is that okay? So once you've done that, then we have to draw diagonals. You need three diagonals, three main diagonals. So you see this line, you draw it here. So these are the main. So here will be positive. You consider them as positive. And this minor diagonal, you consider them as negative. Now, one thing you should note is that for any 3 by 3, look at here, there are two elements that are always free. The one here and this A21 and A22. You see there is no diagonal line crossing these two entry. So now how do you find the determinant? Look at how you find the determinant. You just need to multiply all this term. For example, the main diagonal, the blue one, so you have A11 times what? A22 times what? A33. That will give you this first term. Then you add plus. That is why I said you consider it as plus. Then the next diagonal here is A12. So I'm here now. A12, A22, sorry, A23 times A31 will give us this element. Then finally, this one will be A13, A21, we have this. Then you're done. So for the red one, you go this way. You see A31, A22, A13, which is this. A32, A23, A11 is this. Then finally you have this, which will give us this one. So look at here, there is a minus here. So it means everything here will become negative, right? So that is why I said you consider this as negative. So this method is what we call the Saros rule. Saros rule. But please use it for only what? 3 by 3 matrix to find the determinant. Now, so let's see how this works. Let's take a particular example. Now, look at this now. We want to find the determinant, right? So all we need to do, you can repeat this matrix here. So to find the determinant of A, we're going to copy this same matrix, minus 3, minus 2, 3, 3, 5, 1, 0, 4, 2, 1. Then we're going to what? We're going to copy, or we say we repeat the first two, which is minus 2, 3, 3, 5, 1, and what? And 0. So we repeated just the first two columns. Then we can have our diagonal. So this diagonal, this will go with this one, right? So this will go with this one. So this should cross this line as well. So it's going to be like this. Then, so which one is left? We're going to have this one here as well. Okay, so I will consider all of this main diagonal as positive. Then let's see. Then what will be the other one? So we will have this one coming this way. This, and finally this one. So you can see also in this case, we have two elements that are free, this one and this one. No line is crossing these two elements. So this should be negative, negative, and what? Negative. So to find the determinant now of this, so our determinant is just going to be, the main diagonal is the black lines. So I just need to multiply. I open a bracket. I'll multiply the entries, the element in that in the first diagonal here. It's minus 2 times 1 times 1. So if you multiply that, you should have minus 2. I'll go to the second diagonal, 5 times 2, which is 10, right? 10 times 3, so you have 30, right? So we have this. Then the third diagonal is 4 times 3, but there is a 0. So because you are multiplying by 0, so you have 0 here. Now minus, now you go for the red, the minor diagonal, that's the red one. So you can start from any one. Here you have 3 times 1 times 4, which will be 12. Then here you have 0 times 2, which is just going to be 0. Then finally we have 1 times 3 times 5, which should be 15. All right. So what do we have here? Here you have minus 2 plus 20. Minus 2 plus 30 is what? It's going to be 28 because of the 0, so still 28. Then minus, here we have what? Here we have 12, right? So this is 12 plus 0 plus 15, which is 27. And now what will be the answer? The determinant is just going to be 1. So the determinant of A, it's 1. All right. Okay, so let's go to the last question. Now, this one, question number 4. It says, find the solution set of this. So this is saying that what? The determinant now, please take note. This is not a square bracket, right? This is not a bracket. So it means this is not a matrix. It's already a determinant. So this is saying that the determinant is what? Is 0. So we should find the value of what? The solution set. So how do we get the solution set here? We just need to what? We need to apply the same. We will write, we'll copy this, x 2 minus 1, x 1 plus x, 0, 0, 2, x. Then we'll copy the first two, we'll copy the first two column, which is x 2 minus 1, x 1 plus x, 0. Then we'll draw our diagonal, so we can consider this. And now, what else can we do? We do this way. Yes, so also look at this is free. This is also what? Free. Now, these are the positive ones. And let's consider this now to be negative. So, but now the determinant already is equals to 0. So what? How do you find the determinant? Just multiply this. So you can see that this is x here. This is 1 plus x. So if you multiply, you will have x times 1 plus x times another x. So here it's just going to be times another x. Let's put it this way for now. Put a big bracket. Then plus the second diagonal is going to be x times 2 times minus 1. This is minus 1, so it's going to be minus 2x. Then this was 0 times 2 times 0, so it's just going to be 0. No need. Then minus the red one. Now the red minor diagonal, you have minus 1. There is 1 plus x here, there is 0. But because there is 0 in one of the term, everything becomes 0. Even in the second here, you see that what there is 0 here, so you don't need to think twice. It's everything will be 0 because we are multiplying. And here is just x2 and what this. So we will have what? Plus what? We have plus 2x, right? So this answer is supposed to be equals to what? 0, because this is the determinant. Now, if you multiply this, you have x plus what? X squared, right? Then you still have another x minus 2x. Then this is just going to be, what will this be? I think here I'm seeing 2x somewhere. So let's see what is here. So this is 2x squared, I think. Okay. Let's see, here we had x times this, and this is minus 2x, and this is 0. Okay. Then here it's for the black one. What do we have here for the negative one? This is 0. This is 0. So this is x times 2 times x. So this is square is missing here. All right. So this will be minus 0, 0. So this is going to be 2x squared. This is equals to 0. So if you expand this, we will have x squared plus what? X cubed minus 2x minus 2x squared. It's equals to 0. So this is x cubed, right, which is this. X squared minus 2x squared will have minus x squared, then minus 2x is equals to 0. Then we can solve this easily by taking x as a what? As a common factor. We take x as a common factor, we'll have x into x squared minus x minus 2 equals to 0. So we can factorize this easily as x plus 1 and what? And x minus 2 equals to 0. So here we can have our solution. So our solution set is going to be x equals to what? 0 minus 1 and what? And 2. So this is the solution set. Now, this method is called the Saros rule for finding the determinant of a 3 by 3 matrix. So now to just conclude this video, we've seen how to find the determinant of a 1 by 1 matrix. We've seen how to find the determinant of a 2 by 2 matrix, and we've seen how to find the determinant of a 3 by 3 matrix. So in the next video, I'm going to give you a formula that you can use to find the determinant of any size of matrix, either 10 by 10 or 100 by 100. Now, but before we conclude this, I would like us to know what is even the importance of finding determinants. You know, if the determinant of a matrix, if the determinant of a matrix is equals to 0, what do we say? We say it means that the matrix A is what? Is singular, right? And if a matrix is singular, what does that mean? It means that what? The inverse does not exist. So you cannot find the inverse, right? But if the determinant of matrix A is not equals to 0, then this means that the matrix A is what? Is non-singular. And that means we can find the what? The inverse of that matrix. All right. So now we'll stop. This is the end of this tutorial. I hope everything is clear. If you have any question, do not hesitate to ask in the comment section. Thank you for watching.